Welcome, dear students, to the lecture where we have done the differential equations in the previous lectures. So, in today's lecture, I want to give you the applications of differential equations. How do we use these differential equations? We have done, in fact, the higher order differential equations and what are the methods of solving the higher order differential equations. And also we have done with the first order differential equations. So now where do we use all these differential equations? So the applications now we are going to do. A very interesting application of differential equation is the Newton's law of cooling. So in this lecture, I'm going to make you to understand what is Newton's law of cooling, and I'll just solve one problem to make you to understand the total concept of Newton's law of cooling. So now this particular law describes you how the rate of change. Whenever I say the rate of change, there is application of differentiation definitely exists, correct? So the rate of change of the heat of a body is proportional to the difference in the temperatures between the body and its surroundings. So that is what the law describes. That means, suppose if you take a cup of coffee and the temperature of that coffee is, suppose, let us say some 100 degrees centigrade. After keeping that in a room with some temperature of, let us say, some 25 degrees or 30 degrees centigrade of the temperature, room temperature, what happens? Definitely the heat reduces, right? So the 100 degrees centigrade will reduce into some, let us say, some 75 or 80 degrees centigrade after so and so time of minutes, let us say. So the difference between the room temperature and the temperature of the body, whatever the rate of change is happening, is definitely proportional to the rate of change of the heat of the body. That means whenever I say the rate of change of the heat of the body, I should compare this heat with respect to the time, right? So in this particular period, that means after these many minutes, the temperature has come down, or if you are heating, suppose the temperature has been raised after so and so time. So whatever we say about the rate of change, when we say about the temperature, then definitely it depends upon the time. It may be in the units of minutes or seconds according to the problem. So there should be some governing differential equation for this, right? So what we say is, in words whatever I have explained you now, the rate of change of heat of a body is proportional to, that means the rate of change of the heat is with respect to what? The time. So now I write that T, capital T, is the temperature of the body. Is the temperature of the body, let us say. And then with respect to some time T. So let us say small t is the time, which is with respect to the time we will define. And let us say Tm is the room temperature. That means the body, the surroundings, the body and its surroundings, as I said. The room temperature is generally we denote it by Tm. That is what the room temperature. Okay. So when I say this is what the Newton's law of cooling, so what it says is the rate of change of heat with respect to time. When I say that, it is rate of change with respect to time means d by dt of what? The temperature, that means capital T. And that is proportional to. Proportional to means this one. And what is the proportional to what? The difference between the temperatures of the body and its surroundings. So that means the temperature and the room temperature, that is what the difference. So the rate of change of the temperature with respect to the time t is directly proportional to the difference between the temperatures of the body and the room temperature. Is that clear? So now when I write this is given by dt by dt is some constant k times of t minus tm. So this is called as the governing equation. That means from this equation we are going to find out the solution. This is the governing equation of Newton's law of cooling. Is the governing equation is the Newton's law of cooling. So this is what you have to understand, and you have to memorize this as the governing equation for Newton's law of cooling is this. Is that clear? Now, how to solve this? Now let us understand. Now with respect to time t, we are differentiating. So we will take this as like just it is like a variable separable method we can use, and according to the variable separable method I can now rewrite this as just take dt by t minus tm on the other side. That means dividing by t minus tm on the whole, it gives you k times of dt, correct? Then when I solve this integral, then it becomes dt by t minus tm is nothing but ln of t minus tm. It's just like a this is k times of integral dt is t plus some constant, let us say some, since there is ln, let us take ln c. Okay, so now ln of t minus tm minus ln of c, ln of the constant, gives you k times of t. So that gives you ln of t minus tm over c, because we know the formula about what is ln of a minus ln of b can be rewritten as ln of a by b. This we know. So now according to that those laws of logarithms, we can write this as kt. So also we know one more rule that already you have done in linear differential equations. If I say ln x is equal to y, what is x? It is e raised to y. So we can use that law also, and hence we can write this as t minus tm over c is e power kt. So what is the equation now? We are going to write this as t is equal to, or I will write one more step, t minus tm is equal to c times of e power kt, or you can rewrite this as t is given by tm plus c times of e power kt. So this is what the solution for Newton's law of cooling. So you should memorize this as to find out the solution. What is Tm here? The room temperature. And what is C is the constant, K is the parameter, small t is the time, capital T is the temperature of the body. So you should remember this to solve the problems. So what is the governing equation? Means this is what the governing equation you should memorize, where T is the temperature of the body, Tm is the room temperature, small t is the time, capital T is the temperature of the body. Okay. So this is what the governing equation, and to after solving the governing equation, this is what the solution for the temperature of the body we will get it. So let us now solve one problem by using this particular law. So now a thermometer reading 5 degrees centigrade is brought into room whose temperature is 22 degrees centigrade. So 1 minute later, the thermometer reading is 12 degrees centigrade. So after a minute, the temperature of the thermometer is being increased. And next question is how long does it take? That means how much time it takes until the reading is 21.9 degrees centigrade. So the thermometer temperature is raising. In the beginning it was 5 degrees centigrade. After 1 minute it has become 12 degrees centigrade. If this is the rate of change is happening, how much is the reading of the thermometer? 21.9 degrees centigrade. This temperature, after how many minutes it happens? This is what the question asked. So to understand this, let us do one by one in this. Try to understand. Now the body temperature is 5 degrees centigrade. So the temperature of the body means of the thermometer in the initial stage. Thermometer in the initial stage is what? Is given by 5 degrees centigrade, right? So in the beginning it is 5 degrees centigrade. So it is, we can say that this is the initial temperature. Okay, the initial temperature is equal to 5 degrees centigrade, right? And then it is brought into the room whose temperature is 22 degrees centigrade. So now I call this as capital T. Okay, initially. Now it is brought to the room temperature. So now the room temperature is given by 22 degrees centigrade. So now let us take this problem now. T is equal to 22 degrees centigrade. Now let us see the equation now. What is the equation? The temperature of the body is at the time T is given by T is equal to Tm plus C times of e power kt. Alright. So now what is T here? It is given as 5 degrees centigrade and initial temperature is this, and what is Tm? The room temperature. The room temperature is given by Tm and that is given by 22 degrees centigrade, and C we don't know, e power k we don't know. And now what is the time? The beginning, we can take this as at time T is equal to 0. Understood? In the beginning means the initially it is at time T is equal to 0. So what it gives you, let us see, it is 5 minus 22 gives you C times of e power 0, which is 1. So C is equal to this one. So what is the value of C we got? 22 minus 5 minus negative of this one. So C is equal to minus 17 is the first thing. Is the constant. Your job is to find out what is C first. Afterwards, your job is next what it was given 1 minute later. That means when T is equal to 1. When T is equal to 1. Small t. Please understand the difference between capital T and small t. Capital T stands for temperature. Small t stands for the time. So at time T is equal to 1. 1 minute later, the thermometer reading is 12 degrees centigrade. So what is T? Capital T is 12 degrees centigrade. The room temperature differs? No, right? Room temperature is always constant. So that is 22 degrees centigrade. So these are the things which you know. So let us now call this equation as 1. And now in equation 1, if you replace all this, what we get, let us see. T is equal to 12 degrees centigrade. Room temperature is 22 plus. We know already what is C, that is minus 17. E power k times of what is small t is 1. Okay. So that is 12 minus 22 is minus 17 times of e power k. So that is what 22 minus 12 minus 22 is minus 10 over minus 17. That is given by 10 over 17. And that is the value of e power k. Let us keep this value as it is. E power k value is 10 power 17. We got it. And now let us now find out whatever the given conditions are according to the problem. So what it is now is given by T is equal to your original equation. Therefore, how can we rewrite this? By just plugging the values of C and e power k in the given first equation. What we write? Capital T, the temperature of the body, is equal to the room temperature, which is constant, that is 22, plus the constant is again minus 17. So it is minus 17 times of e power kt. E power k, the whole power t. Can we write like this? I hope you know that e power kt can also be written as e power k, the whole power t. As e power k value, we have got it as 10 over 17. I can rewrite this as 10 over 17, the whole power t. I hope you could understand the equation. So what it implies now? T is 22 minus 17 times of 10 over 17 times the power t. Okay. So with this equation now, we can see the change. When the time is t is equal to so and so minutes, what will be the temperature? Or if the temperature is something is given, what will be the time? Everything we can understand, we can do the problem by this particular equation. Let us call this equation is 2. Now let us go to the problem again. So according to the given condition, we have done that when 1 minute later, what happened to the temperature of the thermometer is 12 degrees. Accordingly, we have made an equation now. Now, how long does it take until the reading is 21.9 degrees centigrade? So, the temperature T is given. Our job is how long does it take? What do you mean by how long does it take? That means at what time T? At what time, small t, that the reading is 21.9 degrees centigrade. This is what you should understand. Let us now go to the problem. So what he was given is at T is equal to what? The temperature capital T is equal to 21.9 degrees centigrade. So with this equation now 2, let's just plug the values. 21.9 is equal to 22 minus 17 times of 10 over 17 the whole power T. Now 21.9 minus 22 is equal to minus 17 times of 10 over 17 the whole power T. Now let us see what it is. It is 21.9 minus 22 is minus 0.1, right? Over minus 17 gives you 10 over 17 to the power of T, correct? Now what gives you 10 over 0.1 over 17 gives you, let us take what is this value of 10 over 17 power, the whole power T, okay? Now let us rewrite this. 0.1 by 17 is giving you the value as 0.0058. You can use your calculator to get this value, and this is equal to 0.5882 the whole power T. Now you should understand one rule, and I hope you have already done in linear, you have already remembered the equation in while doing the linear differential equations. Whenever I write x is equal to, suppose if I write x is equal to, let us write like this, x is equal to y to the power of t. Then how can you take this t outside? That means log of x is equal to t times of log of y. Okay, so now what is log x? Log x gives you, then what is t? Log x by log y. Log of x by log of y. So this value gives you your t. Okay, so this is what now we are going to do. That is log of 0.0058 over log of 0.5882. Let us do one more step here. Otherwise, log of 0.0058 is given by t times of log of 0.5882, right? So now that gives you the value of t. So from here, when you do the calculation, it will be equivalent to some 9.704. So what is this? You can conclude that after 9.70 minutes, that means after 9.8 minutes, you can say 9.7 minutes, the temperature T is 21.9 degrees centigrade. So this is what you can understand. I hope it is clear, all of you. So this is what the way to do the problem by using the Newton's law of cooling. You are given the equation initial time what it is. From that you have to find out the value of C is the first step. After finding out the value of C, the second step is e power k. What is e power k? You have to find out. It's the second step. And then writing down the equation by putting the values of C and e power k by taking the room temperature as constant, you will get another important equation from which you can change either time t is given, you can find out the temperature, or if you are given the temperature at what time t, you can find out. So all these things you can find out by this equation, which is a crucial equation for you. So don't do any mistake in this particular equation. If anything is wrong in this, the whole problem will be wrong. So then now the question in the problem was asked is, at what time t the temperature of the particular thermometer is 21.9 degrees centigrade. So just plug the values of this t and the value of all these values so that we can get the value of the time t. I hope it is clear. Thank you, my dear students.